Welcome everybody to this webinar about de-risking of industrial IoT. We believe that we will have a few people still coming in over the next minutes, but we have quite some information to talk about, so I'll slowly get started with the table of contents. I'll start with a brief definition of what is industrial IoT. Then we'll have a look at what the opportunities are for the industry. And we'll give you one example application and discuss a few more. Then I'd like to talk about the challenges with industrial cloud. And that's the whole risk discussion. Including the possible responses that you can formulate with respect to those challenges. And the main topics are there, the design principles of the cloud application. We have some more recommendations for secure IT, OT combined with IoT and cloud. And we'll talk there about the reuse of available designs and templates that we have developed at Flanders Make. And we'll also briefly touch on the upcoming European legislation, NIS2 for operators and CRA for technology companies. We touched on that also in a little bit more detail in a webinar in last December. But here I will again briefly mention that and provide some references and links. And then we'll talk about further support and resources for you. Just for your information, if you want to interact, you can use the chat, you can use the Q&A, you can raise your hand to be unmuted and ask questions live, and we'll do that at the end of the webinar. All right, so let's get started with definition. Industrial IoT is somewhere at the crossroads of big data processing, Internet of Things, and physical or cyber-physical systems. And you find also Industry 4.0 or smart manufacturing in the same corner. A little bit more precision about industrial IoT. It's about industrial assets, and those can be cyber-physical systems or they can be sensors, a device in any case, and that device has local capabilities, local computing, and on that computing you can run all kinds of things such as analytics, agents, apps, and so on. And that asset is connected to the cloud through Ethernet, Bluetooth, whatever, and thereby it can receive instructions, it can receive set points, it can receive software updates, machine learning model updates from cloud applications. And of course, you can stream data from the asset to the cloud. So you can sort of remotely manage to some degree these industrial IoT assets and the whole, let's say, software, both on the machine and also in the cloud. Good, so that's to just understand what are we talking about. Next aspect that I would like to touch on is the business potential of industrial IoT. So why are we doing this as businesses? You see there's two graphs there. The graph on the left is a graph from some time ago, and it shows the complexity score of the different countries in 2010 versus the complexity score of countries in 1995. And so you see that the well-known high-tech countries like Germany, Sweden, UK are at the top. We in Belgium are not doing. We're doing pretty good. It could be better, but we're doing pretty good. And you also notice that above the line, countries improve, and below the line countries decrease a little bit in technology content. So There is a trend that we should be careful with, and we can also use that potential to improve that technology and complexity content of our manufacturing. Now, what is important about this is that this complexity and technology content is directly correlated with resilience and competitiveness and growth of the manufacturing industry. That is why it is important. So it makes our industry more competent, more competitive. And you can see on the right bottom side what the effect of that is. You see that the Germans are very good at this, and you see that they have more than a quarter of the total industrial production of Europe. And that's not a coincidence. That is because of their technology content. So they show the example, and industrial IoT can help us increasing technology content and technology complexity of our manufacturing. Now, this is a little bit of financial argument. On the right top, you see a diagram that explains how we calculate profit. So basically, we have the average sales price minus the cost, and we multiply that with total production, and then we subtract the fixed cost and the capital cost to get economic profit. And what everyone wants, of course, is to improve their profits. So what are the levers that we have to do that? Well, those are the pink elements there, which is average sales price, cost, total production, and fixed and capital cost. And those are the 5 points you see in the first paragraph. So that's where we want to act on. We want to improve the average sales price, improve the production, increase the production, improve the production value, reduce raw material and utility cost, reduce fixed cost, and reduce capital cost. So how can industrial IoT help there? So we need smart manufacturing solutions using industrial IoT that act on the different domains in industrial production. And those domains are the production itself, the maintenance, the quality, the supply chain, and the inventory. And each of those domains can contribute to those 5 levers. For example, if we improve the production amounts, we have more revenue at the same cost, so we get more profit. If we use predictive maintenance, then we have less breakdowns, so we have more production and we have less cost. If we improve our supply chain, we can reduce our inventories, and so forth and so on. So we can invent many smart manufacturing solutions based on industrial IoT in those 4 domains to get impact on those 5 levers and ultimately improve our profit and competitiveness. So that's why industrial IoT is important for the industry. Good. So here's an example. This is from our colleagues at VUB, the Brussels University, and they make optical lenses for photonics. You see they go through a whole process where they put force and temperature on those lenses. And the result of that process is not always good enough, and so they have to repeat that a few times, actually quite a number of times, to get a good result. And so their interest is to reduce the number of tries they have to do. So what do? Their on-site network, which you see on the left side, has been connected with the cloud via a data factory application. We put that in a database. We do machine learning on those data, and we try to predict what the optimal yellow lines are the predictions by the machine learning. And you see the machine learning has the result almost right away from the beginning. Only the temperature it needs to process a few iterations more. So this is an example how we could get more quickly to a higher quality result, and therefore make more quality production and reduce cost. Just one example. You can think of many others. Good. So we can, I guess, based on this reasoning, we can agree that there is a lot of potential for industrial IoT, a lot of economic potential, and it is not so difficult to make a cloud application for industrial IoT. What is difficult is to make a secure cloud application. And that's a little bit where the risk comes in. So here is why the cloud is risky and what you can do about it. You see that the published vulnerabilities are increasing exponentially. This is information from the German government. How did we get there? Why? Because we connect our industrial networks on the left side with our control and business networks to do all kinds of important and interesting things like collecting data, optimizing control, updating software, and so on. But at the same time, we introduce the risk that people from the outside come in through our networks and make changes on the equipment on the production floor, and that can be very dangerous. It can be annoying. It can stop the production, but it can also be physically dangerous. Now, in terms of the possibilities for setting up a cloud, there are basically two categories. The one category is the industrial cloud from automation and instrumentation providers. So you buy a sensor and they provide you a cloud and you can see the value of the sensor on a cloud dashboard. And you buy another sensor from another vendor and you get another cloud and another dashboard. And you buy an equipment and you will do your predictive maintenance on a third cloud. And so you can imagine that for a few applications, this may be completely okay and work fine for you. But if you have many applications, this can become somewhat inefficient, especially if those clouds are not connected with each other. So then you have the option to use industrial cloud from the big companies like Microsoft, Azure, Amazon, or Google. And there we discovered that this needs very careful architecting, and it is not really out of the box to make that really secure. And what we would recommend is making a very good design. We'll show you a few principles to make a good design. And once you have that design, to use a templating approach so that you get consistency in the resources you deploy. And also apply automation so that you can redeploy an application. And if you do it in a modular way, you can actually redeploy components into different applications in a very consistent and repeatable way with little effort. But there is an upfront project to do to make that work. And so our recommendation is to work with competent partners. We have our own partner here in the call if you want to ask questions. So very briefly, there are many, many more things to discuss, and we're happy to do that with you offline in another setting. But just very briefly, a few ideas. Identification and authorization needs to be under control, especially with a hierarchy of rights to reduce the risk. You need a secure network design, both on premises in your equipment, but also in the cloud. We'll show you a figure below that illustrates that a little bit. And it reminds me of the fact that this slide is much more detailed in the handout that you can obtain if you give us an evaluation for this webinar. And what we also recommend is to have selective access for specific users to specific areas. Give an example, only quality control people can access the quality control applications, but not the production applications or the logistics applications. And then there is, of course, a connectivity between the on-site, on-premises on the one hand and the cloud on the other hand. And so to do that safely, we need a site-to-site encrypted connection using virtual private network. The OT security has also to do with networking, but there are a few other things, and I'm giving some other hints in the handout. And then there is the security of your software itself. So software code can have vulnerabilities, and there are two aspects to it. There is commercially software that you sell commercially, and in-house built applications if you are a user or if you are a technology company. And very, very soon, we will have a European law that requires that we keep those systems safe. Especially if we sell them, we need to be certified, and we need to keep those systems safe over the life cycle of the product. So it could be embedded software in an equipment, or it could be just software on itself, but we have the obligation to keep it safe. What is recommended in order to guarantee that safety is to do an analysis that we call software bill of materials. And we are getting some experience with doing those in an automated way here at Flanders Make. And then, of course, there is the software that you purchase, which is a different situation. And for the purchased software, again, if it is just software or if it is embedded software on a controller or a motor, it is our responsibility as users to monitor the vulnerability databases and patch the software to keep it safe. And that's a NIS2 obligation. So here is a networking example on premises. So the higher level are the enterprise IT networks, and we have the usual IT security, and it needs to stay that way. That's of course very good, but for our manufacturing equipment, it's not good enough, and we need to separate the networks from each other using a firewall. We'll separate both what we call the buffer zone or the demilitarized zone, which is the yellow zone in the middle, where you have your servers, and we again will separate from the manufacturing applications. That can be production, it can be quality, it can be logistics applications, but we separate all of those from each other to make it very difficult for people and software to enter those zones and to create problems. So the most critical zone is, of course, your production zone, and that needs to correspond to the highest security standards. And we're doing exactly the same thing in the cloud. It looks slightly different, but the principles are exactly the same. Good. So with that in mind, what should you do? Again, I insist on the fact that if you don't have experience, then please use a trusted implementation partner. We have implemented our industrial cloud system together with a partner called Codit, and it was a significant project, but I'm totally, absolutely sure that without them, we would never have had reached the same quality result in the same time. And what you should do is request relevant references and require compliance with the security standards that I'll show you in a minute. And we can help you suggesting requirements for choosing a partner. We have made many designs and we have made templates, and those templates can be reused. And if you decide to use an Azure implementation, Microsoft Azure implementation, we are prepared to share our designs and templates because it's not critical intellectual property for us. So this is a complicated slide. Basically, it summarizes all the guidelines for cybersecurity, and those are aids. Those are they help us becoming more secure. And some of them are in the IT space, some of them are in the IoT space, other ones are in the IT and OT space. And they all flow together in the Belgian Cybersecurity Center, CCB, who have a cyber fundamentals framework. And we're really, it's a really advantage, I think, for Belgium that we have this concise, let's say, set of recommendations and also questionnaire and suggestions to improve our cybersecurity. So I really recommend using their information and doing their assessment. To come back 2 seconds to the EU cybersecurity regulations, there are basically two main topics. The one topic is the Cyber Resilience Act for technology firms, and they require the cyber secure products during the product life cycle. And then we have the NIS2 directive for operators, which is the make industry. And the two work together. So the users use safe products, and if they find a vulnerability, they publish them, and the technology firms need to look into those published vulnerabilities, repair them, provide patches that the make industry then should install. So those are two tightly related regulations. I'm giving you the links to the most relevant information that I have. NIS2 will be effective October 17, and the Cyber Resilience Act is still in discussion in the European Parliament, but we recommend to take action as soon as possible. So for your IT, OT, industrial IoT, cloud, and networks, we recommend you anticipate the regulations, NIS2 and CRA, and you name a security responsible or somebody who has also security responsibility. We recommend you do the assessment of the Cybersecurity Center of Belgium. You decide where the weak spots are and what you need to improve, and you do that in successive iterations based on your priorities. And my recommendation would be to combine that with functional safety activities, because you need to analyze your equipment anyway. You can just add the cybersecurity to that analysis. And then when you reach the target levels, you can implement a process for regular assessment and updates. And what is also important is that the board and the management are responsible for cybersecurity. So they need to be aware of what's going on. They need to provide training and means to the people, and they will need to make the decisions around cybersecurity. So how can we help you further? We can help you further with more detailed awareness and knowledge transfer. For technology providers, we can help you making your first software bill of materials. We can have a look at with you how to publish vulnerabilities, looking how you can use advisories for software that you purchase, and give you hints for preparing for the Cyber Resilience Act. For user operators, some of this is similar. We can help you making the landscape analysis, defining your security zones, getting started with a few quick fixes for your foundational requirements, setting up automated consultation of vendor-published vulnerabilities and software bills of materials, help you with establishing a process for industrial cybersecurity assessment, making software bill of materials for the software that you make or buy yourself, and define a roadmap for assessment and implementation. We're also working on a 2-day course for technical and general leadership, where we explain more about industrial IoT, and in the future, possibly for technical and IT managers. For now, we have two projects that we participate in and that are partially subsidized. There is the IoT SBOM Cook project that is focused on knowledge transfer and software bill of material analyses. And we can provide 2 days of free consulting to production companies. And you see our contact information. We're also participating in the European Digital Information Hub Digitalis, and the two actually work together so that we can provide you a total package where we can look at cloud security, on-premise security, software security, and also connectivity security. So that's what we can bring, and therewith we're open for questions.
Okay, thank you, Valentin, for the interesting presentation. At the moment, we don't have any questions in the Q&A or in the chat. Maybe the easiest way, if you have any questions, just raise your hand. I will allow you to use your mic and even your camera if wanted. And then you can ask your question directly. So if you have any questions, just raise your hand. I don't see any hands yet. I'll still give you some time.
So, is there anyone who would like to tell us if this was too dense information or maybe too fast? Would you like to hear more about some of the topics, maybe? Can you tell us about that? Anyone who wants to chip in?
If someone starts, everybody will follow, of course. So if we have one volunteer.
Is there anyone who has experience with analyzing security of networks and improving them? And do you recognize what we're saying here? Did some of you think about software bill of materials? Are you aware? And there is Alberto Stefanini.
Yeah. So Alberto, at the moment, yeah, you can use your mic and also your camera if wanted. So please go ahead.
And I mean, materially, I have done several things in this area with mostly with Italian companies. So the key question is how do you envisage to collaborate concretely? I'm referring to the last slide you presented.
Concretely, well, I think we will start with a discussion and see where your needs are. I mean, the more independent and competent you are, the less help you will need. But we can see between your and our competence where we can maybe provide some additional added value. If we can help you with an SBOM, but you can do your own networking analysis, that's fine. If it is vice versa, it's fine too. So we try to provide a package from which you can choose components, and then I think we need to decide where you want to dive in and where you want to become practical. So and one of the things that
some summary of what we did here, what I have done here in Italy, I guess.
We would be very interested to learn about that, of course. Absolutely. It's not in our KPIs, but we're very, very interested to learn. The KPIs of the Cook project is to help you innovating. So to identify areas where you could improve or innovate. Research, development, manufacturing processes, whatever is appropriate for you, and thereby increase your cybersecurity. That's our point. So the government is promoting this to make you more less vulnerable and more competent.
Okay,
Right.
thank you. Other questions or remarks? No. No reaction anymore. Of course, if you
Oh.
still have any questions or remarks, you can also send us a mail afterwards. We will.
You can contact us. We are happy to discuss, and we're happy to answer any questions. And when you do the evaluations, you will receive the handout, so you can also read it once more before you ask questions. It's completely up to you. In any case, many thanks for attending. It was our pleasure, and we hope to hear from you. Bye.
Okay, thank you. Bye.